All right, the word problem review. Now, I know people do not like story problems, so this could be a bit of a stretch. What we have here is Diana could do 4 jobs in 7 hours, and Frank could do 7 jobs in 5 hours. How many hours would it take them working together to do 10 jobs? So we're looking at rate times time equals jobs. So let's look at the rate of Diana times the time plus the rate of Frank times the time equals 10 jobs. That's what we're looking at doing. Now I have to find the rate of Diana. Well, they gave us information up here. So let's see, the rate of Diana. She did 4 jobs in 7 hours. And the rate of Frank is he did 7 jobs in 5 hours. So what we're going to do is substitute those into the rate and solve for time. So we have 4 over 7t plus 7 over 5t equals 10. Now I need to find how much time it would take them to do this. The rest here is just algebra. So if I take and multiply everything by 35, what I'm going to get is 35 times this one, 35 times this one, and 35 times this one. That gets rid of the fraction. 7 goes into 35 5 times, so I have 20t, plus 5 goes into 35 7 times. 7 times 7 is 49t, equals 350. And now it's a relatively easy algebra problem, which ends up being that many hours to get the job done, which is we could put it into fractions or into whole numbers, but that's not necessary. Let's look at example 2. In example 3.2, Patricia could do 5 jobs in 10 hours with 3 machines. And using the same rate, find the time it would take her to do 4 jobs with 12 machines. This is a typical industrial engineering problem where they want to know how long it takes to do something and if they need more machines and if they need more people. So what we have here is rate times time times machines equals jobs. Well, we want to know what the rate that Patricia had. We are going to solve for rate. So she did 5 jobs in 10 hours with 3 machines. So if I'm going to solve for rate, then what happens is I'm going to have her rate be 5 jobs divided by 30 machine hours, or 1 job in 6 machine hours. So that is her rate. Now what we want to do is find out how long it's going to take her to do 4 jobs. So again, back to this formula here. We're going to use the same rate. 1 job for 6 machine hours. And we want to know how long it's going to take her, so we're looking for time. And we said we have 12 machines. And we're going to do this in 4 jobs. So I have to solve for t. So now what I have is I've got 12 divided by 6, so I'm going to have 2 jobs per machine. Okay, the machine goes away, and I get 2 jobs per hour times time equals 4 jobs, and I need to find time. So I'm going to solve for t. This is 4 jobs divided by 1 hour for 2 jobs. Jobs goes away, and it's going to take her 2 hours to do the job. All right, I'm going to read to you example 3.3. It's in your book. Walter and John found the cost varied directly as the number who worked and inversely as the Saber-Cat index. So using those words in the first sentence, we found that the cost varied directly. So we're going to call this a constant of variation. Varied directly as to the number who worked so I'm just going to call it N for number who worked, divided by, because that's inversely, as the Saber-Cat index. So I'm going to call that S. So that's what they told us. Now the cost was $400. When 5 men worked, 5 is the number worked, and the Saber-Cat index was 8, and we can solve for K. So when I solve for K, I get 400 times 8 divided by 5 equals K. Well, 5 goes into that 80. 80 times 8 is 640. So there's my constant of variation. But we're not done yet. What would be the cost? That's what we're looking for. What would be the cost when 13 men worked? So my constant is 640. 13 men worked, and the index was 2. So now I've got 2 going into that, 320 times 13, which ends up being $4,160. Now you could do it that way, and that allows you to find K first and get the cost from there. But it's taking your word problem and writing down what you know and finding an equation. All right, in example 3.4, it tells us the cost varied linearly. So when you think of linear, think of a slope-intercept form. So what I have here is the cost varied linearly with the number of men who worked. So I have a slope, and I'm going to call it the number of men who worked. And we have no idea what the y-intercept is. It could be 0, it could be anything, but we have to first find out the information that they gave us. So when 10 men worked, so when I have 10 men that worked, the cost was $70. When 20 men worked, the cost was $120. And then they want us to find what's the cost. Find the cost when n equals 2. So when you only have 2 men. So I've got to find my slope and I've got to find my y-intercept. And I have 2 equations and 2 unknowns. So why don't I write the equation down? 20m plus b, 70 equals 10m plus b. And I'm going to subtract this bottom one. Why did I do that? Because I can eliminate this b, and now I have 10m equals 50, and so m equals 5. That is my slope. So now if I have my slope, I can choose either one of the previous equations and find my b. So let's take the 70 equals 10 times 5 plus b. 70 equals 50 plus b. So b equals 20. Now some of you will think, great, I'm done. Well, no, we just found the equation of the line. The cost equals, my slope is 5 times the number of men worked plus my intercept of 20. Now I can find the cost when n equals 2. 5 times 2 plus 20, and the cost ends up being $30. And that is taking a story problem, writing down what you know, and then solving for those unknowns, and then answering your question.